According to the standings, we achieved a result of 57%. The response revealed that oil production is on the plateau. Apparently, we did not have time to raise the pressure. The liquid also decreased, but since we shut off B1, this is natural. The injection has increased, water cut on the plateau.
101, I don't see any problem here.
Yes, you can leave it as it is. Similar situation for well 102. Water gas shutoffs on well 103.
Well 104. There are no channeling or after hydraulic fracturing. The formation has a normal production target. The same goes for well 106. Can be optimized.
Water gas shutoffs on well 107 and well 108 too. At well 109 can be optimized.
110. Strange pressure behavior. Water shutoffs.
And we measured the reservoir pressure there, didn't we?
Well 111, similar situation. Well 112 injects at a maximum limit.
60 is injecting. Can we perform bottom hole treatment, or it has bad reservoir properties?
Whether or not it makes sense, we have to look at the situation from the offset producers. 113 is currently pumping. 114 pumps at the maximum limit of 70 cubic meters.
Can we reduce the injection? The downhole pressure is too high.
It seems to me that there will be no breakthrough here.
There will be no breakthrough, as it pumps at the maximum possible limit.
There is an obvious auto-hydraulic fracturing at well 115, so well 112 must either be removed or limited. The same goes for well 116. By pumping excess water into these wells, fractures are formed.
That is, we limit 112, 113?
Initially, no for well 114, probably because it pumps into an overlying formation. We can, however, limit the wells 112 and 114. In case of well 117, it's not clear where exactly it's pumping to. It's necessary to further perform production logging. Regarding well 118, there are no channeling or after hydraulic fracturing. The formation has a normal production target.
40 cubic meters of pure oil, but the pressure is still not enough.
The same goes for well 119.
Look, we have shut off reservoir B1 in these wells, and oil production declined by 20 cubic meters. It turned out that by shutting off the reservoir, the production declined.
Yes. As an option, we can enter the pay zone of reservoir B1 so that oil can be obtained along with water.
What do you propose?
They are already operating at lowered pressure.
Or we can increase the pressure and thereby increase the flow rates. Let's look further at well 120. It is operating just fine, no injection needed, but again there is not enough pressure. The pressure at well 121 decreased, so we have shut off reservoir B1.
122, it seems to me that it's necessary to reduce the rate. 123, the same. We can put 50. The same situation for 124.
125, the pressure is depleted. It is necessary to drill an injector, and there is not enough well that were converted from producers to injectors. 126, we can optimize it a little.
It is not possible, because the bottom hole pressure is already at a minimum.
The same goes for well 127. The pressure has restored a little. 129, reduce the production target. 130, optimize. 131, water shutoffs. 132, optimize. 133, at the norm. 134, optimize, or is there a breakthrough there?
For well 134, it is necessary to call production logging.
At 135, we reduced the production target. At 136, also reduced the production target. At 137, also reduced the production target. At 138, we have stopped the production decline trend, the well has stabilized and the water cut is not high.
E3, I suggest leaving it as it is.
E4, high downhole pressure. It seems to me it is necessary to drill formations.
We can call production logging. S1 is operating fine, it can be further optimized.
S2 cannot be optimized.
The pressure there is in increasingly short supply. Still, I think that it is essential to drill injectors.
We will do it in the south. There are just additional pressure maintenance conversions that need to be made.
And in the north?
We already have a 1-to-1 ratio of producers and injectors here.
That's why I say that it is necessary to drill.
Let's place a vertical producer in the area around well 107.
We don't have enough pressure there anyway.
There is a trap there.
There is an undeveloped area and we assume that the reservoir pressure is almost the same as hydrostatic, correct?
Yes, that's right.
So as an option, we can withdraw some reserves there. What options for further redevelopment are there for the fourth shot? I'm trying to say that there is not enough pressure. I would like to direct your attention to the injector wells, but I agree with the petrophysicist. We can drill a producer there behind the fault in the area around well 107, where the pressure is still good.
Convert S2 to pressure maintenance and drill a horizontal well next to it.
That's a good idea.
And we don't have enough funds for anything. Maybe we will drill 2 vertical producers again, because the effectiveness of the horizontal one is questionable.
S2 started producing 40 tons. The horizontal well can provide 80 tons maximum.
And S2 will raise the pressure?
S1 started producing 100 tons. Then why aren't we planning to drill a horizontal well at this area?
Then 2 wells will remain without pressure maintenance, and beyond the fault, here to the northwest, the pressure is almost identical to the initial. If the pressure depleted, it was marginal. There you can see the horizon for 2 shots. Again, what are we going to do with the pressure maintenance? I also think that S2 should be converted into injector. The flow rate is very small compared to the expected value. Reservoir engineer, what are your ideas?
We have lost a lot in the primary wells. I propose a drilling strategy of 1 well in the north. We will test it out and make a decision whether to convert it to producer or injector. The rest of the money is for the primary wells.
Does everyone agree?
Is there a horizontal or vertical well in the north?
I suggest starting with a vertical well with hydraulic fracturing.
I propose to drill 2 wells after all, and perform workovers on the remaining wells.
Which ones, producers or injectors?
And where are we going to drill?
The first well will be drilled around the same level as 106-107. The second is in the area around S2, but more to the east. And based on the open hole data, decide which well it's going to be.
It makes sense to drill northwest. S2 can be converted to injection judging by the logs.
And how this will affect S2? I don't quite understand.
If we drill a new well, and there will be water, then we convert it to injection. If there is oil, then we convert S2 to injection.
It's too far away, and the wells are isolated. The logic is not clear. Let's drill the well behind the fault, and based on the results, we will understand what we will do in S2, which is located in the external reservoir boundary.
I would still advise to convert S2 to the injection.
So we will decide based on the formation thickness, oil saturation, and is it better than the corresponding properties in S2?
I'm not sure that we will increase the pressure there quickly with wells 107, 108, S2, but something will still get there. That is because there is a connectivity there.
The connectivity between the zones behind the external reservoir boundary and inside the external reservoir boundary, there is no influence on each other. So, the question is, whether it is worth drilling there or not. The answer is yes, but it's not worth to convert S2 based on that information.
Can we first drill where I am pointing the cursors to, below S2?
There will already be water there, and we will be able to somewhat maintain the pressure.
Yes, you can drill there, but I still recommend drilling in the area around 107. There is a trap there that is not connected with this dome.
It's just a way to gain extra funds.
The first one should be drilled to the west between 107 and 108. The second one, where I am pointing the cursor to.
So you propose to drill 2 vertical wells?
Yes, if the well that the cursor is pointing to has oil, then we convert S2 into injection.
Or maybe it's better to convert the new well into injection. The pressure at S2 will increase, and we will get a flow rate increase there. I think that there are more reserves in the area around S2. There is simply not enough pressure there.
Can we drill the formation and maintain the pressure at well 109 and S2 through an injector?
I like the idea of drilling a horizontal injection well. The only thing is not clear is how effective will it be if we perform it at the last shots.
Let's go back to the structural map. There is a trap in the northwest. We need to drill there.
I completely agree.
But I still suggest to convert S2 to injection.
There is a trap there, at the same level as well 106, on the red line 150. It must drill there.
And what to do with the pressure? How do we increase it?
S2 should be converted to injection if it influences 109.
If we drill behind well 106 to the west, we are guaranteed to get money, and for maintaining pressure in the north, we are going to convert S2. Simulation engineer and reservoir engineer, please state your opinion regarding this matter. I suggest that it is safe to drill into that trap and then we decide.
Yes, let's drill and perform workovers on the northern block. I'm against of converting S2. It's better to apply remedial jobs at well 108.
You are against converting S2 to an injector, but you are in favor of workovers and injectors.
Yes, we need to make a reservoir profile. Let's see where it injects to. It will be much cheaper. If we need to make sure B2 is operating, we'll perform stimulation, optimize it, but we are not going to drill a new well. This is an inappropriate use of funds.
What about well 107?
It's still a little far away. It rather influences 103, 104, etc.
That is, you suggest to leave S2 as it and let it produce, but to work with the wells in the northern block and also perform drilling in the northwest.
I completely agree.
Okay, then we are going to drill and then look at the workovers. Geologist, please provide me with the coordinates.
Perhaps closer to the well 108 or lower.
I think we should go a little further west.
Yes, we can do that. We will still encounter hydraulic fracturing.
Yes, we can do it there.
And can you state the depth?
Around 60-90.
The well is a producer. The total cost is currently being evaluated.
Do we account for hydraulic fracture in there?
Yes, I started to look at the open hole data. After that, we make a decision. Okay, let's drill.
1660 is B3, an oil-bearing reservoir, but the water starts below 1664.
So we are performing hydrodynamic logging.
Yes.
Depths are 1620, 1634, 1662, 1680.
1680, this is B3.
No, 1680 is C. 1663 is B3. 1636 is B1. It's just B2 and B3 merged into one unit.
Yes, we saw it on B2. We had different pressure in B2 and B3, despite the fact that they were connected.
No, B2 is a small subunit, which is almost absent.
All right, the results are back.
We need to lower it a little.
We need a perforation.
Yes, let's do it. Perforation from 1632 to 1636, a barrier of 3 meters, and again we need pressure.
Are we going to add a perforation to the top of reservoir B3? So we are going to add 4 meters of perforation.
Maybe we will perforate above 1661. There is both oil and water, but we will have a good inflow.
We can, but there is a barrier between them with a water bearing of just 1 meter. If the pressure is not enough, we will lose production.
There is low permeability there. If there will be a flow, it will be marginal. So let's finish adding perforation.
Let's then make 1656 to 1660.
Okay, so we decided on the perforation. Let's apply them.
I have a suggestion. Let's make the upper perforation a little lower, so that we won't have a limit on injection bottom hole pressure.
We are already doing it 2 meters lower. We leave alone the high permeable sublayer.
So this means that the barrier is not 3 meters, but 5.
Good.
Then I will now state the perforation intervals.
I'm listening.
1632, 1636, 1656, 1660. Will we perform hydraulic fracturing?
Yes, I say we make it.
Is it necessary?
Are we going to produce some water?
It's true. It is only coming from the underlying formation.
Maybe into the bottom part of B1 to cover B2?
Maybe we initiate a fracture at 1636.
Yes, let's do it. Now that we have finished with well F3, let's now switch to workovers at the northern blocks. There are well candidates for production logging. These wells are 103, 106.
So, we are done with drilling.
It seems to me that the pressure isn't high enough there, even at the area around S2.
I propose to spend $1 million on the old wells. The conversion of 125, 126, B1 will bring 25 tons each.
Let's just start from the north. 107, 108, I suggest to survey.
Let's take well 108 in the middle, perform reservoir flow profile, and it will be clear what are our next steps.
Let's look at the production logging.
Yes, here we see the channeling from overlaying and underlaying formation.
Well, we see that unit B11 is completely washed out.
Let's still use the previous experience to only shut off reservoir B11 so as not to lose reserves.
Yes, let's do it for all. I just suggest that in addition to that, we shut off a couple of meters of B12, just in case.
Water gas shutoffs at well 108 from the well head up to 1595 and from 1645 to bottom hole. Similarly, tell me about 107.
Petrophysicist, please join the discussion. We are shutting off B11 from the wellhead.
Well 107, from the wellhead up to 1597 and from 1668 to bottom hole.
Let's apply these activities.
Also, well 103 from the wellhead to 1603.
All right, applying now.
So we have performed walkovers for 3 wells in the north.
What are we going to do regarding E4? And also count well 110. Maybe we'll make a production logging on it and see where it injected to.
Yes, let's make a reservoir flow profile and then make the decision.
And let's see what to do with S2 there.
Using this analogy, we can understand 111 later.
And also we need E4.
Now we have received the result of well 110.
Here we see the channeling from overlying formation.
Do we still need to measure the pressure?
Yes, we can measure it and say what kind of pressure we actually need. Perhaps we can increase the production target here.
Here we have a weighted average pressure between the reservoirs B1, B2, B3. At least we got something. Let's measure the pressure.
Please state the well number.
110.
Let's give it more days to restore the pressure.
So the pressure is 12 bar.
Will we shut off B1 until the end?
No, since we leave B12 there. Technically, we don't need the pressure there. We'll just withdraw more. What are we going to do with 111 and E4? Do we think there is no channeling in these wells, or do we perform a reservoir flow profile?
E4 clearly has channeling.
Will we do the reservoir flow profile?
We have performed water gas shutoffs at wells 107, 108, 103. Let's now focus on well 110 and well 111.
111. Let it inject in the same way as well 110.
Is there a channeling or not?
Do we really want to spend $1 million on reservoir flow profile?
Just for some reason the pressure in this zone does not increase. We have only three possibilities, E4, 107 and 108, so somehow we need to increase the pressure in this zone. If this does not work out, we need to think of something else.
Let me express one idea. Don't you think there is a hydrodynamic connectivity with the zone at 110, 111?
It seems that there is no connectivity. Let the simulation engineer answer this question. So, please tell me, is there a hydrodynamic connectivity between the northern block and this zone where 110 and 111 are drilled?
Yes, technically there could be.
Through which reservoir unit?
I will take a look now. B1 and B3 can be connected.
B1, which is in the appendix, with B3 in the north?
Yes.
That is, the well 110 is stealing water from B3 in the north. Is this somehow critical?
109 and S2 are producing from 3 reservoirs.
We have performed hydrodynamic logging at B3. The pressure there is 133 bar.
139 bar.
So depletion was insignificant. It turns out that this is the liquid that goes to the area around wells 110, 111. Technically, they do not have a high production rate. We can limit it a little. What do you say?
I may be wrong, but I see a hydrodynamic connectivity, and I propose to convert 110 and 111 into injection.
Where is the hydrodynamic connection? The unit B3 has a low permeability of lower than 10 millidarcy. However, at the wells 110-111, there is a high permeable unit. We can perform a reservoir flow profile on well 109 and see whether or not there are flows along B3.
We can look at 108 and decide based on that. It's not ideal to perform reservoir flow profile here.
Well 108 is far off from this zone.
It is clear that there is no inflow. Let's forget about this layer then.
Now we can rate the pressure at the northern block. To be honest, I don't see any other alternative except to convert it. I understand that there is already an excess number of injectors.
Yes, a big excess.
How much does well 109 produce? S2 produces about 25 cubic meters of oil.
50 cubic meters.
That is, well 109 should be optimized?
Maybe. As an option, we haven't done E4 yet. We can see if it produces or not.
Let's work with E4 because we need to do something.
Colleagues, what do you say? Are we going to perform production logging on E4?
According to E4, the production logging for it has already performed and is available in the initial specification.
Yes, we have performed water gas shutoffs, but we didn't get any response. What is the problem?
Have we shut off overlying and underlying units?
Yes, we have closed everything. I will open the response for this well now. It's still a suspicious well. Can we redo production logging at this well?
Yes, let's do it.
I agree, yes.
The injection is important to us now. We will need to check the well. Okay, let's perform reservoir flow profile. We got the result for E4. Here, we see the channeling from overlaying formation.
There is a breakthrough in B11.
Let's completely shut off B11.
Yes, let's do that. From the wellhead up to 1620, and let's apply it. 110 from the wellhead up to 1645. 111 from the wellhead up to 1650. It seems to me that we have done everything we could at the northern dome at the moment.
We still have $841,000 left.
Let's move on to the main southern dome. There was a significant number of activities performed there, if I am not mistaken.
We have made almost all the water shutoffs we could there. There is still well 113. It is injector, technically. I think it is possible to shut off reservoir B1 and redirect the injection into B2. Should we do that?
We wanted to measure the reservoir pressure. As I understand, we have to perforate the unit B1 in wells 118, 119 and 121. I also advise to measure the pressure before and after perforation. Let's go one by one. 103.
Producer for 2 days.
109.
Producer for 2 days.
110.
2 days.
113.
Injection 5 days.
115.
Producer 2 days.
117.
Injection 5 days.
118.
Producer 2 days.
119.
Similarly,
121. 124. 125. 127. 130. 132. 133. 134. 135. 137. 138. S1. S2.
We wanted to make a perforation to B1 too.
No, I have conditionally defined everything.
I am applying the activities.
Now we will find out the reservoir pressure and we will also measure it after we reperforate B1 too.
So, team, the results have come back.
At well 103, the pressure is as high as 126. We almost restored it to the initial pressure. At well 113, the pressure is 111, low pressure.
The well operates at all three layers.
And in well 117, the reservoir pressure is low.
Surprisingly low pressure, considering that it is injection well.
127, very high, 170 bar, although it is an injector. 125 is a producer, and the pressure there is already 179 bar. I believe we went too far with the injection. 132 has high pressure, and the pressure at 135 is 321 bar.
It is an injector, but the reservoir pressure is still of great importance.
We need to limit it right away, because you see well 137 is located next to 138, and in the injector the pressure is 264, and in the producer 117. Yes, I believe we have raised it a bit. When do we reach the radial flow at these wells? There are three formations with different permeabilities. When we look at the reservoir radial flow, for example in B1, however, we do not know what is happening in B2, B3. I mean, it is necessary to look at the pressure where only B2 is perforated, and to look when the radial flow was established.
We don't have such wells.
Simulation engineer, please help me out.
We had wells that are only active in B1. The rest are in B1 and B2.
There is always B1 there.
Then it is the actual time when the radial flow established in the reservoir B11.
Well, okay, it's too late. Let's finish drilling the reservoir units at wells 118, 119 and 121.
Yes, we will perforate B1. Let's look at the history data.
Do you know what else we can do regarding establishing a radial flow? Is to shut in injector 135 for 15 days and measure formation pressure there.
Okay, let's do it after the perforation. Well, 118 is on your screens. You need to inject to B1. Can you please provide me the intervals?
Didn't we already perforate it?
We were shutting off B1.
Now we need to perforate B1 too.
With the help of B1, we want to withdraw liquid, and of course oil.
But we'll no longer be able to set such production targets.
Why is that? We can go back to getting 170 cubic meters and 60 tons.
Yes, let's do it.
Let me ask you again, do we need to perforate B1 too?
Yes, otherwise we'll lose production rate.
Also overlap a little bit?
Yes.
Then 1610 to 1615.
The same goes for well 119.
1607 to 1612.
I don't think it makes sense to perform it at well 120. It is possible to do it at well 121.
1613, 1618.
Okay, so we are done with 3 wells now.
I'll take a look now. There is no point doing the rest, I believe.
And how much money do we have left?
Enough. I propose to make a reservoir flow profile at well 134. Most likely that there is a channeling there.
So yes, we wanted to do it at 117 and 134.
Let's take 134 first.
Can you also perform reservoir flow profile on well 131?
And also on well 117. Yes, correct. The results came back. 117. Here we see the channeling from overlaying formation.
It injects pretty well. Can we do bottom hole treatment there?
I don't even know whether to increase the injection or whether it is not effective. It flows somewhere beyond the external reservoir boundary. I just can't get my head around the state of the well.
That it has a marginal injection?
At the same injectors that also operate at the same reservoir have a bottom hole pressure value of 150 to 200 bar. And for some reason, this one only has 127 bar.
Let's perform bottom hole treatment.
But why?
To increase it, it has a marginal injection, 13 cubic meters.
We just need to increase the injection and that will solve the problem.
And what was the downhole pressure at that well?
The reservoir pressure was 96 bar. It is necessary to increase the injection.
No, but what is its bottom hole pressure?
It is very low. Since we inject at 170 bar, we need to increase the injection.
Again, it turns out to be 300. Can a simulation engineer tell us what to do so that there is more injection to well 117?
We can put 400 there, since there is only unit B2 there.
Yes, let's just increase the injection. And perform water gas shutoffs at well 134. It seems to me we also shut off the overlying formation and reservoir B1.
I agree.
Approximately from the wellhead up to 1622.
Better to do it until 1625.
Okay, fine. What about well 131?
And have we already performed water shutoffs on it?
No, I propose to inject it at along with B1 and B2.
Will it help if we stimulate or perform hydrofracturing?
I don't see the point.
Alright, we'll leave it out.
Additionally, we shut off unit B1 at wells 131 and 134. In 134, for example, let's make it until 1625.
It is necessary to shut off 131.
I agree, but at well 134, it is necessary to perform water gas shutoffs.
In 134, yes, I support it.
Well, let's shut it off at 131 up to 1620 then. Maybe it will at least hold at the level. I just don't like the fact that the entire water flow comes from a high permeable reservoir, and we are fine with this.
And what is this?
There are still reserves here, right?
Therefore, I advise not to shut it off completely, but up until 1620.
So we leave a very small interval?
Leave one perforation at least, but at least something will go through.
Alright, let's do it up until 1620. Okay, I am calling the activities.
Workovers are rather time-consuming.
Let's move on. We still have $435,000 left.
In my opinion, it's necessary to sacrifice well 118 and convert it to injection.
I agree, we need to do more conversions.
We will sacrifice a lot.
We have already managed to enter pay zone of B1. The entire injection will go to B1. We have just finished adding the perforations.
I know.
So, are we converted?
Yes, let's do it.
But why did we add the perforation then?
The whole point is to get an increase at wells 119 and 121.
It would have worked without it. Alright, I am making a call.
Are we going to convert S2 in the north? We will withdraw 25 cubic meters.
I suggest leaving it at 25 tons for now.
Well, that is not a lot for a new well. It's all because of the pressure. I believe that this raw 106, 109 will slowly collect 25 cubic meters, as we will increase the pressure. This is the plan.
Since we have made the drilling, I suggest we investigate this zone and leave S2 as a producer for now. And if S3 will be involved in production, when will we drill a new well at the next step? Convert it to injector.
It doesn't make sense to do it at the fifth shot. The last opportunity now is to work with the pressure maintenance, because there will be no point of maintaining the pressure at the fifth shot.
Another option is to convert well 126. Again, we will lose a lot, but we hope that there will be an increase at 125 and 127.
What is the production rate at 126?
40 tons.
It is actually 30.
Well, let's convert it.
If you look at how wells 125 and 137 operate, there is clear potential.
I agree.
You can convert the 127. There are two options here.
Now let's convert 126, because it will immediately operate at 125 and 127.
That's it, we're doing the conversion.
And how much funds do we have still left?
$215,000.
And what can we use them on?
Let's keep the money.
That's all. We leave the production targets too.
We are limited by liquid in this, the reason that the injection is poor.
Yes, of course. I believe that well 101 should be left in the same production target. The same goes for well 102. 107, let's also leave it as it is right now. 108, let's also leave it as it is. 112, let's set 80. 113, I propose to leave it as it is, because it has a good production. 114, let's set it to 70. 117, increase to 350. 118, I advise to set 100. 122, I suggest leaving it at 70 because it couldn't produce that much. 133, also 70. 134, 100. 126, to put 100. 129, also 100. 131, leave as it is. 135, let's limit it and leave 300. The same goes for 136. 137, reduce to 100 or 90. E3, leave it as it is. E4, let's also leave it as it is.
We have completely shut off reservoir B1 in E4.
If we have shut it off, then 100 cubic meters at E4.
There is an excess of 159 cubic meters. Let's assign it somewhere.
So we can slightly increase, for example at well 102.
Perhaps we can perform it at new wells.
It is probably not worth to make it there. Yes, let's leave it as it is.
Producer wells.
At 103, suggest to leave 100. At 104, 80. At 106, let's leave as it is. Well, 109, also leave it. For well 110, 160. For well 111, also 160. 115, there is not much production potential there. So let's leave it is limited to downhole pressure. The same goes for well 116. Restrict is to bottom hole pressure. 119, 100, 120, 50, but we will set 60. 121, we managed to recover, so 140, 125, just 80. Let's leave it and let's hope the pressure will come back.
Team, in 116 and 119, we perforated B1. Can we still increase production there?
We didn't perforate 115 and 116, but we did perforate 119 and 121.
We perforated 3 wells, 118, 119, and 121. Yes, we have done all. Then the next well is 125.
I suggest leaving well 125.
I suggest increasing it.
There is not enough pressure on it.
It will receive from 126.
The pressure will not reach so fast. At well 127, I suggest leaving it 100, as it cannot perform better. 130, there is clearly potential, 100. 132, let's set 120. 133, 90. 134, here we have limited it. I hope it will work. Let's set 150. 138, 120. S1, 140. S2 has a poor performance, so let's put 50. S3, 60.
Can we increase S1 a little bit?
The pressure will still decline for now. Everything is fine.
Its bottom hole pressure is holding stable for now.
It has a bottom hole pressure of 105 bar.
I think everything is fine as it is. We have set 140.
Let's place the shot. They grew a little bit and declined again due to the pressure.
101 is currently injecting. The same situation with well 102.
Well 103 can be further optimized. 104 can be further optimized. 106 can be further optimized.
107, we need water gas shutoffs. 108 is also water gas shutoffs.
109, water shutoffs. 110, 111, they are working at their limit.
112 works at the maximum limit.
We can probably reduce it. 113 works fine. 114 operates at the maximum capacity. Regarding well 115, we shut off B1, but it didn't help. Does it make sense to convert it into injector on the 5th shot? But it is clear that it will not get anywhere. The same goes for well 116.
Water gas shutoffs were performed at well 117, if I'm not mistaken.
Yes, it didn't help.
118 has a normal injection.
We will now see how it influenced well 119.
The bottom hole pressure has increased. It is necessary to increase production.
120. Despite that we converted 118, it does not affect 120. The water has not reached yet. 121. Okay, and even the pressure increased. It will be possible to optimize the production target on it. 122, can I still reduce the pressure?
We can leave it as it is.
The same goes for well 123, the same goes for well 124. 125, no response from pressure maintenance conversion. We converted well 126 and it is currently injecting.
But the injection is marginal. Either we increase production rate or perform hydraulic fracturing at wells 125 and 127.
Well 127 is normal, the pressure is increasing.
No, the pressure is at the minimum.
But the liquid is increasing.
There is still not enough pressure.
The pressure is still low, 129.
A similar well, like 124.
130, the pressure is rising. It is necessary to optimize.
131. It is necessary to restore the pressure. 132. The water cut is growing.
For some reason, we are not able to fully optimize. I don't think that this is a huge injection flows from 136 to B1. The water broke through. We are doing okay on well 133 and managed to make some reconstructions at well 134.
There is a high downhole pressure.
We can adjust it in the next shot.
Yes, we have to adjust it as much as possible. As of now, it has a pressure of 150 bar. Well, 135 has a bottom hole pressure. Pressure at 136 is at the minimum level. Well, 137. Stable operation at current production targets. Water gas shutoffs were performed at well 138, and reservoir B1 was shut off.
We have lost oil. We shouldn't have shut it off. There is enough pressure. We can increase production rate.
E3 is currently injecting and is able to reconstruct the pressure. E4 is also injecting. We just limited it a little. S1, we increased it a little, but there is still not enough pressure. Our 136 well in 2 kilometers does not reach the liquid through the aquifer.
Nevertheless, we did increase it.
Can we drill a well next to it?
S2, we need water shutoffs. S3, fine.
It is possible to withdraw liquid here. Now let's see if we can drill producers nearby and convert it to the pressure maintenance.
How much funds do we have left for this shot?
$2 million.
So we have the opportunity to drill at least 2 vertical wells, and probably it makes no sense to perform workovers.
138 is our tested well.
138, perforate the upper sublayer.
103, optimize it.
Will we measure the pressure to plan a strategy for the 5th shot?
Well, only if it is going to be around S1 and S2. At SE3 we see an injection bottom hole pressure of 140.
But I still suggest to convert S2 to injection. We don't really care about 20 cubic meters it provides.
We can convert it. Drill a new producer below.
Let's now drill a well. Look at the saturation and decide what to do next.
Geologist, petrophysicist, please provide your recommendations regarding drilling new well in the south of the northern block. How does our team compare now to the reference scenario?
Okay, let's see. We are at 54% of the reference.
It is necessary to increase production during the last shot.
I propose to do hydraulic fracturing at 125 and 127.
Let's drill a new producers, and we will understand what to do with the remaining funds.
All right, geologist, can you help out? So here's the problem statement. Now we want to drill a well approximately in the area where the cursor is located. What are the exact coordinates and down to what depth to drill?
Maybe closer to S2 if we now convert it to injection, so there is an effect over the year.
I agree, yes.
The pressure is depleted. It will give 30 to 40 tons, and there will be no much point from it.
It is possible to make it closer to S2, somewhere around 60-70.
Have we ever found oil anywhere in this zone? Therefore, can we try to drill close to S1? Also, we receive 100 cubic meters normally. It's okay?
So what decisions have we made? Are we going to drill in the north? One in the north, one in the south?
We will definitely drill.
We can start from the south if you want.
Let's go a little higher, where I'm pointing the cursor to.
Yes, tell me where.
A little higher. What will the geologist say?
Yes, we can do that.
So, team, do we start drilling then?
Let's take a closer look. S2 is at B2. S3 is at B1. We can get into the fault.
If you want, I can open S2 and S3 on two screens.
No, I want us to discuss a bit more. How do you think in the well S2 the thickness of B2 was higher? And is it poor now?
The open hole S2 is on the left, and S3 is on the right. Can we compare them somehow? Perhaps it will help.
Since we're developing B2, and in S2 it is represented by a large thickness, it may be necessary to drill closer to it.
Yes, it will be better to be closer to S2, especially if we are going to convert it now.
Can you please open the map? After all, I believe that there is the border between green with blue.
I suggest to be closer to S2 in this zone, but this is purely my opinion.
We can go a little higher.
All right, team?
I don't mind if we don't get the fault.
Well, the fault just ends somewhere here.
Does anyone else have any comments?
I agree. And one well for S1.
Yes, that's right. I support it.
So we drill?
Yes, let's do it.
I moved the cursor a little. Is that okay?
In case the permeability is good, it's fine. We also need to look at the bottom part of the reservoir.
So down to what depth should we drill to?
We can make it 1670.
And it is definitely not lower? Isn't the slope too steep?
It shouldn't be. At the depth of 6078 in S3, there is a water-bearing formation, and in S2, it is much higher.
Producer, right?
Yes, a producer for now, and we are going to convert S2 to pressure maintenance.
And if we drill two wells in one go near S1, how do you like this idea? So what we were granted more funds on the next shot.
Let's apply this first.
No, if we apply this, then we will not be able to drill two wells there. I suggest instead of this one to drill two wells near S1. The bottom hole pressure there is about 80 bar. It will be enough for one shot. It will provide more funds.
Geologist, can you tell me which zone will be more promising in terms of saturation?
According to the current result, we have a higher production rate in the area around S1.
Okay, let's discuss it. We have a perforated reservoir B1 and we made a hydraulic fracturing on B1 too. It is possible to drill two wells, one injector and one producer.
What will the others say?
Are we going to convert S2 into an injector?
Wait, we haven't decided exactly what we're drilling here. The well testing specialist had the idea to drill in the area around S1. So what will the most beneficial simulation engineer have stated that according to the operation of S1, the well has a good flow rate?
And for the next shot, if it provides at least 80 to 90 tons, it will suffice.
Well, there is a bit of a problem that it will be slightly lower, and saturation will also be probably lower. You sure this will work?
Maybe. But what about other promising areas? Are there any?
I agree, it's a risky business.
As an opinion, we will also drill another one in the area around S1 and 138.
Let's drill.
So we completely ignore the northern area.
Please open the production target for well 138. It has a production rate of 25 tons and a low bottom hole pressure.
Well, we can perforate B1 there and see what happens. If we confirm that B1 is there, we'll acquire around 70-80 cubic meters.
We can measure the pressure in 138 and in S2.
We measured the pressure 138 last time. It was 126 bar.
Well, let's take the measurement again to have a better understanding.
Alright, it doesn't cost much.
Yes, technically it has a moderate cost. Which wells are measuring now?
138 and S2.
We are applying it. Soon we will get the results.
At well 138, the pressure is 183 bar. We have managed to raise it and it looks promising.
Which sublayer is it located in? Just the high bottom hole pressure.
At well 138, we produce from B2 and 1 meter of B1. Well S2 has perforated B1 and B2 3, if I'm not mistaken.
Well, then let's drill in the area around well 138, perform hydraulic fracturing and set the maximum production target, because the well produced 200 cubic meters of liquid and 70 cubic meters of oil, which is 65% water cut. When all the reservoirs were perforated, however, the bottom hole pressure was 40 to 45 bars.
All the options are interesting. Which option are we going to go with?
From the perspective of reservoir pressure, drilling at the southern part of the southern block is more attractive, more promising. In the north we would not be able to raise the pressure, but if we converted S2, perhaps we could withdraw something.
And where do we put the drilling data point? Around 138 or S1?
There are 3 possibilities and we need to choose 2 of them. I agree with the simulation engineer. We need to perform it around well 138.
If you look objectively, S2 will provide 40 to 30 ton if we convert it to injection. I don't think that will provide 80, so it is better to perform it around 138. Well 109, in fact, also provides 20 ton, although it has good injection bottom hole pressure. Probably it is better to perform it near 138, because these wells do not produce much oil.
How about in area around S1?
I'm afraid there will be thief injection.
The well testing specialist stated that we will have a high starting production rate. However, the production rate will decline by the end of the year.
And we can spend the remaining funds at well 103, where we will convert it to pressure maintenance and we will have 20 million left.
So are we going to drill in the area around S3?
It started producing poorly, just 10 tons.
There may be an overflow. It's unclear what we are opening. Perhaps it's better to perform production logging there.
It's possible, but this doesn't apply to a new well.
We need to understand where the water comes from the reservoir or channeling. You can try production logging.
Perhaps we have enough funds left for 3 wells?
Unfortunately, we only have money for 2 activities.
I also believe that we require additional injectors in the north. At the same time, there are sufficient reserves left in the area around S1.
Alright, here's my proposal. To drill 2 producers south of 138 and northwest of S1.
Okay, let's drill these 2 wells, and in the north we will convert S2 or we will leave it as it is.
But then again, we will lose 20 tons. We will be able to recover that through wells 108 and 109.
Can 109 be optimized?
It's possible. We can raise the production rate there 2 times.
Then we can in fact convert it into an injector.
What was the bottom hole pressure at S2? 40?
The minimum was 45.
Maybe we should try to increase production here and keep producing from both wells.
Do you propose we perform hydraulic fracturing?
We have already made hydraulic fracturing there.
And yes, another hydraulic fracturing will not help here. We only made hydraulic fracturing at one layer, and if we perform it on another,
The water was nearby.
we have performed it on underlying formation. What if we do the same on overlaying formation? This is just a suggestion. I might be wrong.
There was a 3 to 4 meter shale break between the reservoir and aquifer.
Perhaps we shouldn't make hydraulic fracturing, but rather perforate 2 to 3 meters and try to increase production. I'm trying to understand the best way to withdraw the reserves at the final shot.
Let's first drill the wells.
Yes, let's start with zone 138. Tell me the coordinates for the new well, or we can drill it closer to the other wells.
Probably it is better to drill it closer to 137.
Geologist, tell me down to what depth to drill. It is both not far and slope will not be steep there.
Technically, we can try 1690.
Do you agree?
Yes, let's do it.
$693,000. The well has been drilled. The open hole data is shown on the screen. We need to select data points for hydrodynamic logging.
It seems like it turned out perfect.
We will leave B11 for now.
So we are only going to go with B12.
B12, we already have information on B2. B2 we will perform hydraulic fracturing. We only develop B2 in that areas. Has B1 already been shut off?
Yes, we have shut it off. It turns out there is no production rate there. We need to further perform hydraulic fracturing. On 138, you can also try to do hydraulic fracturing on B2 instead of adding perforation to B1. And what is we first perform hydraulic fracturing? Simulation and then production logging.
We will leave out B11, right?
No, B12 only. And at B2 we will perform hydraulic fracturing.
Okay, let's try. Can you state data points for hydrodynamic logging?
Probably 1605 and 1650.
Will we isolate the aquifer or not?
Did you take B11?
Do we need it?
Don't we need it for general analysis?
Let's do it then. Okay.
Petrophysicist, please look at wells 132, 133. They currently have a high production rate, 40 to 50 tons. Is it possible to make hydraulic fracturing there now so that the remaining reserve will be recovered in one shot?
If we are talking about B2, then of course we can do that there. Well, 131 can be stimulated.
Let's first do hydraulic fracturing at a new well. Look at the production logging results, and then we can understand if it will be reasonable to perform it at other wells.
Yes, let's do it.
Hydrodynamic logging data points are 1,597, 1,605, 1,640. We take the measurement.
While it is calculating, let's discuss if we are going to perforate B12.
Yes, we will.
I also think that it is necessary.
B12 perforation, B2 hydraulic fracturing.
Team, the result came back. B1, very high reservoir pressure, most likely from injectors.
We did a good job at this block.
Let's perform the perforation.
Are we going to perform it on B1?
1605 to 1610.
I believe 5 meters is good. How about making it lower?
1640 to 1655.
We have entered the intervals. Let's apply them.
Yes, and we will also need hydraulic fracturing.
Can you state the data point?
1641 will do.
Okay.
As I recall, the well testing specialist suggests that we also perform hydraulic fracturing at well 132.
Team, are we going to do production logging on S4 or not?
I don't see why it is necessary.
There is not enough pressure.
There is pressure yet. There is no permeability. The pressure is very high there. We have injected way too much into it.
Let's try it. We have performed production logging on S4. Is it possible to make a well flow profile, or will we still go with the reservoir flow profile?
Better off with the reservoir flow profile.
Team, we have the reservoir flow profile results on well S4. We see that there is a flow of pure oil at B1 and the water inflow at B2.
This is just a cross-flow from B2 to B1.
Which direction? Are you not concerned that there is pure oil in one reservoir and water in the other? If there was a cross-flow, there would be water in the other reservoir as well.
Therefore, we cannot give information.
But we got the result. We are sure that it will produce at the low water cut. We are putting it into operation. We are setting the second point. I asked geologists to join the conversation and provide the coordinates and depths.
We should make it a little lower.
Okay.
Yes, it is fine.
Will it be an injector?
It will be a producer that will generate some money.
Okay, can you state the depths?
Just like S1, only deeper.
Yes, that's fine.
Let's apply. We open the open hole data. I suggest to perforate B1 completely. What do you say? Or just B1?
Let's add perforations and perform hydraulic fracturing.
Hydraulic fracturing from the bottom data point?
I think we should ask petrophysicists about this.
We need to perform hydraulic fracturing approximately where the cursor is pointing to, 1652.
Okay, one more question. Are we going to perform hydrodynamic logging?
We need to do this because the barrier is 4 meters and we need to know what kind of pressure is required.
Okay, what are the data points? Do we perform just one or two?
1630, 1640, and 1650.
Let's do it.
And we didn't measure S1? Perhaps it is not wise to spend funds on it.
We did measure it.
Wait, it's been 5 years already.
Perhaps we should compare what was the value then and what it is now. Now I am applying the activities. The results came back. The pressure in the aquifer is 188 bar at B1, 99 and at B1, 125. Perhaps we should compare the aquifer results during the first well that was drilled. The pressure was 170. So, there was a trend of some kind. Let's add the perforation.
I suggest B11, 1640 to 1644, and the next one, 1646 to 1654.
Why is the upper interval so small? Why don't we start with 1642?
Yes.
Can you state the intervals, please?
1640 to 1644, 1646 to 1654.
We have successfully applied the activities. Are we going to perform hydraulic fracturing?
1654 or even 1652.
Okay, let it be 1652 then. Let's apply the activities. That's it. We are putting it into production. There is $395,000 remaining.
I suggest we take a look at 132 and 133 or 108, which is more promising.
120 is also promising.
What about 108?
It is injection. 106, there is 109, 104.
We need to perform it on one of them.
138. Do not need hydraulic fracturing there?
And yes, we missed this. It also has a low water cut. We can try it. Let's try to develop that zone.
The pressure there is too high.
And the bottom hole pressure seems to be minimal. I just wanted to increase production where there's still some oil left and not on the flanks. That's why I wanted to try 132, 133, or 104.
Here in the south, there are promising wells: 120, 125, 132, 133.
What is the production rate of well 132?
It's good.
Not very good.
And what about 133?
The water cut is almost at 40%. Technically, it is a promising well with current production rate of 50 tons.
However, it has a water cut.
What if we consider well number 125? It is clear that it has a water cut, but the water cut is less than 20%.
If we perform hydraulic fracturing, it can provide 200 cubic meters.
What is the production rate for it now?
50.
Let's try it. Team, what do you say?
Yes, let's increase the production by 3 times.
The water cut, of course, will increase.
But the liquid production will also increase.
Yes, it was already over 100, but we will at least know whether it is worth doing hydraulic fracturing at these units.
We need to look out so that the water will not flow from 126. So what is our plan?
Yes, let's take a chance.
Let's try well 125. We need to select a data point.
1632. Have we perforated B2 there?
Alright, am I making a call and we have $307,000 left? We can make one water gas shutoff.
Perhaps we should finish adding perforation to well 138 if it is not enough.
Yes, it is better to finish adding the perforations.
Alternatively, we can perform water gas shutoff.
I haven't seen any possibility for water shutoff.
Let's quickly run through the wells to have a better understanding.
At 103, it's not clear. What can we do to benefit?
I agree. We tried to perform water gas shutoff and did not get what we wanted.
There is well 132. Can we try to do something about it?
Let's try it. It's just located at the crestal area.
Well 133 is working perfectly fine.
Yes, 40% water cut, 45 tons.
Can we also shut off the B11?
We can try. Team, what do you say?
Yes, let's do it.
Isolating well 132. Please state the intervals.
Up to 1610, do we completely shut off B1?
No, we will not shut off B1 entirely. Let's do it up to 1589.
Alright, applying now. We have a little money left. We can do a couple workovers. I propose to make a hydraulic fracturing at wells 120 and 133. 120, 1646, 133, 1651. Perforations on B3 at well 103, 1650 to 1660. We have no funds left. We just need to set production targets and call the shot.
101, keep the same. 102, 150. 107, keep the same. 108, keep the same. 112, make it lower like 50. 113, 200. 114, 60. 117, 350. 118, 100. 122, 75. 123, 70. 124, 100. 126, 40, or we can leave it at 50. 129, 100. 131, 300. 135, 300. 136, 300. 137, 100. E3, 80. E4, 100.
Okay, we have some residual reserves left here. Will we redistribute them?
I don't know, should we? Where can we put them? At 136 or 135?
At the northern block if possible.
Let's put the most in 108 and E4. 108 400, E4 200. 137 200.
Now, regarding producers.
103, 250, 104, 150, 106, 200, 109, 150, 110 and 111, 200, 115, 100. It works on the maximum potential. There is 20 in general. 116, 100, 119, 200, 120, 60, 121, 200, 125, 80, 127, 100, 130, 150, 132, 120, 133, 90, 134, 250, 138, 200, S1, 200, S2, 150, S3, 250, S4, 150, S5, 150.
Alright, let's call the shot.